Greetings everyone. Today we're going to explore graphing and writing hyperbolas, specifically those that are translated. Remember, if you need the basics of a hyperbola to see my other video at the origin, make sure you're in the right spot in your notes and let's get started. First, let's quickly review the parts of a hyperbola. You already have this in your notes from the previous lesson, but we need to understand where the center is. And in this video, we're going to move that center away from the origin. We, of course, have our vertices, our foci, and the asymptotes. Now, because we're translating and moving that center point, our asymptote lines, we're going to be wanting to write most likely in point slope form or translated form. So that'll take a little more information in this video. The only thing that we're changing in our formula and our general process today is going to be this minus h and this minus k. So because we're moving away from the origin, we're changing those values. Remember that in a hyperbola, whichever value comes first is what matters because this is subtraction. The size, the value of any number doesn't matter. It matters what comes first. Don't forget the pieces of the formula. You're never going to be given all the values. You're going to have to find something. And so our hyperbola equation has a subtraction sign in it, which means our formula to find c has a plus sign in it. Remember that a is the distance from the vertex to the center. B is the distance from the vertex to the asymptote. We will stick to horizontal and vertical distances that you can count. And then C is the distance from the center to the foci. So let's jump right into example 3. In this example, you'll notice we're already equal to 1. So everything is set up perfectly for us. We have our subtraction sign, which tells us that this is a hyperbola. And you'll see that the y comes first. Because the y comes first, that means this is going to have sort of a vertical orientation or an up and down. Our center point is based on the values inside. It says the x plus 4, so I'm using negative 4. It says y minus 1, I use positive 1. So negative 4, 1 is going to be our center point. I'm going to draw it right away. Our a value, because order matters, a squared is always first. So because a squared is 25, my a value is 5. A is the distance from the center to the vertex. So if I go to my vertex and I need to go up and down, I need to go up and down 5 units. 1, 2, 3, 4, 5. I need to go down 5. 1, 2, 3, 4, 5. Now, let's label those right away. When we're labeling our vertices, you'll notice they all keep the x value because it's the up-down value that changes. So really, I'm taking that 1 from the center, and I'm adding 5, and I'm subtracting 5. So you could calculate it without a graph as well. B value. B is the distance from the vertex to the asymptote. And so b squared is always second. So if b squared is 9, my b value is 3. Now, some students get forgetful and they think, oh, it's from the center. But if I was to draw from the center, I wouldn't have any asymptotes, right? And so you'll know pretty quickly, like, well, that doesn't make sense. I need to go 3 east and west from my vertex because my goal is to have slanted asymptotes that create this perfect x and create that orientation of an up-down hyperbola. Let's talk about those equations next. I'm going to jump ahead to the asymptote equations. Now, we can't easily do slope-intercept form because I don't know where these asymptotes cross the y-axis, and they might not cross nicely. And so I recommend translated form, right? So the slope, right, we can just count 5, 3. That's our B value. Rise 5, run 3. One of them is negative. Sorry, that negative was a little last minute. And I'm going to recommend translated form. So what that means is I would recommend taking the center point because that point is part of both equations. And if it says my x value is -4, I write +4. And then for vertical shift, we know on translated form, it stays as is, so a +1 on the outside. And so I recommend now, technically, you could do any point on the line. Technically, you could do point slope form. I recommend this as a way to just make it more streamlined, use the numbers you already have, possibly make it a little faster for you. All right, let's talk about our C value. I need to do a little bit of calculating here. A squared is 25, B squared is 9, that gets me to 34. So C squared is 34. If I square root both sides, let's see, does square root of 34 break down at all? It doesn't, right? And so I'm going to say C is the square root of 34. Now to graph it and to write it as a focus point, because this is a dot, it's from the center to the focus. What's the closest perfect square to 34? 36, right? So this is a little smaller than 6. So from the center, I'm going to go a little smaller than 6. Look how close that is to our vertex. So it makes sense, its location, right? If it was closer to the center, it wouldn't make sense. Now I have to write those as points, you guys. If we draw dots, we write them as dots. And so my x value is the same for both. We're going to use that -4 again. But the y value from there, here's where translated changes things. We have our y value of 1. We need that 1 in there. And we're going to add square root of 34 from that. And we're going to subtract square root of 34 from that. See what I did there? You need to add and subtract from whatever the center value was. That's where translated sort of adds a little more detail. Of course, do not forget to draw those parabolas. Those parabolas go through the vertex, follow along the asymptotes. You want them to look, you want your drawing to just really look symmetrical. All right, let's take a look at example 4. We have a little bit of setup on this one first, you guys. I need this to be equal to 1, so I have to divide everything by 64. Now, in our class, I will always make sure that it divides perfectly. So, for example, here, 16 fits into 64 perfectly. We're going to stick to that to keep things sort of streamlined. All right, that would get me to a 4. Remember that everything is based on what comes first. The x is first. That determines that this is going to be a left-right orientation. My center point is based on what's being added or subtracted. So I have a +1 and a -4. Don't forget those opposite signs. So 1, -4. My a value, it's based on order. The first one is a squared, so that means a is 8. That means from center to vertex is 8. Kind of big, right? So let's draw this out. We're going to go 8 to the right because it's left-right orientation. We're going to go 8 to the left. So to write those, notice the y value stays the same on the center. And we're going to take that 1 and add 8 and take the 1 and subtract 8. All right, our b value. My b value is based on the second piece. B squared is 4, that means b is 2. From each vertex, we're going to go 2 in the opposite direction. So 2 north, 2 south. We need to go that direction so that we can get that perfect x that we're looking for our asymptotes. And I apologize, your drawing is going to be much better than mine, but you're used to that by now. Let's write those equations right away. So asymptote equations, we are going to do translated form. My slope, use your AB. We rise 2, run 8. Rise 2, run 8 reduces down to 1/4, and we also have negative 1/4. Translated form. We're going to use our center point. Our x is positive 1, so we write negative 1. Our y stays as our vertical shift. All right, last piece. Let's talk about our c value, our focus. We got to do a little bit of work. A squared plus b squared equals c squared. 64 plus 4 equals c squared. That means c squared equals 68. I need to square root both sides. I'm pretty sure that breaks down. Let's see. 4 fits in. I'm getting 17 times. So my c value will be 2 square root of 17. Now I need to think about where that would be. What's the closest perfect square to 68? 64, right? So we're just going just past 8. That makes perfect sense. So when I write these dots, we have to change our x value. The x value on our center was 1. From that 1, I added 2 square roots of 17, and I subtracted 2 square roots of 17. And my y value remained the same, negative 4. See how I literally took that center point, I tried to color coordinate, and I just added or subtracted to one of the values. That's going to be the biggest change that you're going to have to really sort of slow down and think about. As always, don't forget to draw that picture, all right? We got to go through our vertex, cruise along the asymptotes. Please make sure there are arrows on the end. You will have some times in our class where you're going to go off the graph. Just go with it. You know, we can only make so many clean, nice values that fit on a 10 by 10. So sometimes we have to go off the graph a little. All right, let's jump into writing. So what if I'm given points? What if I'm given a graph? How do I write my hyperbola? And so to start, similar as previous lessons when we talked about ellipses, I encourage you to set it up first, meaning, oops, sorry about that. Oh my goodness. Set it up first. So equal to 1, parentheses squared. This is a hyperbola, so it's subtraction in between. Okay, that's where we gotta slow down a little bit. Notice my order matters now. This is vertically orientated. That means the y comes first. Okay, that's based on the direction. Now let's talk about our center point. If it's on the graph, let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 3. I'm getting 8, 3. So what that would mean, my x I'd write -8, my y I'd write -3. Our first value is center to vertex. 2 jumps. My a value is 2, so I'm going to write 4. My b value is from vertex to asymptote. We can just count again. So from here, let's go sideways. 1, 2, 3. That means my b value is 3, so I'm going to write 9. So again, if you're given a graph, you just got to count it out. But what if I'm not given a graph? Now I find graphs easier, so your notes likely don't have a blank graph. I would encourage you to use a marker board or graph paper. I threw one up on my slide here, and I'm going to draw a little picture to try and make sense of this. So let's start with our vertices. Our vertices are at -10, 12. So I'm actually off the graph here a little bit. My other vertex is at -10, -8. All right, so as I recommended but did not follow my own advice, I encourage you to set it up first. So when I look at those vertices, in my mind I've got this picture here, right? That if those are the vertices, this is my orientation. So what that means is the y comes first. All right, next we need to find our center point. If I know my vertices, I can find the middle. The middle's obviously going to be at negative 10 something. The distance from 12 to negative 8 is a distance of 20. 20. If that distance is 20, that means my A value is 10. So 10, if I go south of 12, would be at 2, or 10 from negative 8 would still be 2, right? So negative 10, 2 is my center. So let's fill that in. My x says negative 10, I write positive 10. My y says positive 2, I write negative 2. My A value, we said A is 10, so that means my first number is 100. A always comes first in a hyperbola. Gotta memorize that. B value, I need some asymptote information, so let's talk about these points on the asymptotes. Negative 2, 12, right, would be right here, and negative 18, negative 8. Oh gosh, you know what? I don't even need that, you guys. Right? We know it's going to be symmetrical. Let's go from this top vertex to that point. Let's just count horizontally, meaning from that y value of 12 to that y value of 12. See the pattern there? We care about the distance of the x's. So look for that. You could actually look and say which ones have the same value. Those do. The distance from negative 10 to negative 2 is a distance of 8. Now you might be like, well, what about the other points? Guess what? You could have done that with the other points. If you saw the pattern, negative 8, negative 8, you could have said, oh, what's the change from negative 10 to negative 18? It's still 8. My b value is 8 no matter which way I count. And so I can write 64 under my fraction bar. Again, if you don't have a graph or a marker board, I mean, even in my personal notes, I just did a little sketch. I just think it makes it easier. So again, personal preference. Let's start with vertices. Nope, I lied. Let's start with setting it up because that's what I recommend. Making sure you got that so you can just fill in the blanks as needed. All right. Vertices. Vertices are at 10, negative 8, and 0, negative 8. So that kind of gives me this picture, right? If those are my vertices, we're going left to right. What that means is my x comes first. All right, the distance from 10 to 0. 10 to 0 is 10. That means halfway is 5. A is 5. The distance from the vertex, or between the vertices, is 5 in each direction. So that means my center is at 5, negative 8. See how I found the middle? Those of you that want to do midpoint formula, you could do that. Then you wouldn't need a graph. Midpoint formula would work great. So we're going to write that my x is going to have a negative 5 and my y is going to have a positive 8. Okay? All right, let's figure out our denominators. If my a value is 5, my first value is 25. Right? It's first. If it's a, it's first. Let's find our b value. Oh, well, I don't know any asymptote information. I know my foci. Let's talk about that. 18, negative 8, and negative 8, negative 8. So I can't even draw 18. So let's worry about this one. Negative 8. Remember what our c value is? C is the distance from the center to the focus. The center to the focus. If this is at negative 8, negative 8, the distance from 5 to negative 8 is 13. Which means I'm going to have to do some calculating to find my b squared. Okay, so let's talk about that. Let's set it up. A squared plus b squared equals c squared. That's our focus formula, right? A squared is 25. I don't know b squared. That's what I'm trying to find. 13 squared is 169. if I subtract 25 over, I get 144. And I don't even need, I mean, it's a perfect square, but I don't need it to be because b squared gets written under my other value. All right, one more example. I know this has been a long one, you guys, but we try to really throw every scenario we could throw at you within the constraints of our class. And so it leads to more examples. So let's take a look at this last one. Points on the asymptote, that's a little different. We're at 12, 2, so I'm off my 10 by 10 graph, that's all right. And 6, negative 6. 1, 2, 3, 4, 5, 6. So I might be off a little bit, don't mind me if I am. So that means this is an asymptote. Not much information, so let's keep going. Foci are at 9, 3. I'm going to write a little f there to remind myself. And 9, negative 7. That gives us a lot of information, actually. So I'm just going to envision, if that's my focus, that means I've got some kind of parabolic shape this way and parabolic shape this way, right? So the focus can get us our center. So let's set up what we need because we already know some information. And the information we know is that this is now vertical. So y comes first. All right. Let's find our center. Our center is going to be in the middle of our focus values. So that means it's still got to be at 9, right? The middle value between 3 and -7, that's a distance of 10. So a distance of 5. Wait. I just said a distance of 5. That means C is 5. Okay, let me just put that out there because that's the distance from center to focus. Okay, 5 would get me to -2. How's that sound for a center? So that means I'm going to write x minus 9 and I'm going to write y plus 2. And again, if you have a graph, right? Wait a second, look at that. My asymptote goes through it, so I feel like more confident if I do graph it. We know our C value, but that's not helpful. I still need an A value and a B value. Let's see what else we can find out. Now, the points on our asymptote, let's talk about that. The points on our asymptote are going to be horizontally, if I was to count horizontal from there to sort of this line of symmetry, right, where my center is, if I count horizontally from this 6, -6, that'd be 1, 2, 3, a distance of 3. Do you see how I got that? Distance of 3. So that means my B value is 3. Okay, we can count that. So that means this is going to be a 9 under here. And here, when I counted to that line of symmetry, what I was doing was counting to the vertex. That dot I just created is the vertex right here. So that means that vertex exists at 9, -6, which means the distance from 9, -6 to my center point at -2 is a distance of 4. My A value is 4, which means 16 is my other denominator. Now, you might have thought I was assuming here, but we will in our class give you the values on the asymptotes that are horizontal or vertical from the vertex. Now, outside of the bounds of our class, could you be given other points? Yes, but we'll make it so that it is a countable value. We made it, we did it. I encourage you before any assessments to maybe consider just re-listening to this. It's a lot to write down and comprehend at once, and maybe just re-listening to it when you're doing something mundane might just help you understand it. You know, you're not going to understand and memorize this all from one shot. So another way, of course, is to check Google Classroom, see what your practice is. The more you practice, the better you get at any skill in life. So please check that out. Let me know if you have any questions, and until next time, have a good one.